This demonstration will show you how to graph the data from the Enzyme Lab using the software Excel. We will use data from a fictional experiment that examines the effect of different gasolines in cars. First, let's open the Excel software. You will see a blank spreadsheet with columns and rows to put in your data. So let's enter the data now. For the demonstration, we tested the effect of different gasolines on the same mark of car. We measured the distance each car traveled over 10 seconds from a stationary position. The data was collected every 1 second. Time is the independent variable, and it is plotted on the x-axis or the abscissa. We will put in this information in the first column. The distance the car travels is the dependent variable, and it is plotted on the y-axis or the ordinate. For this experiment, we tested 4 different gasolines. So let's label each column where we're going to put the data for each gasoline tested. In this instance, I've imported data I previously generated, but you will put in your data that you collected from the Enzyme Lab into this particular space. Now the data is recorded into the spreadsheet and we can go ahead and graph it. The software helps us here, and it provides many options for graphing the data. We're going to select a scatter plot option. The first thing we do is to highlight all of the data. Then we're going to go to the Insert tab. Within the Insert tab, go to the middle section and select the scatter plot option. Click it once to get a submenu of additional options for scatter plots, and pick the scatter plot with a straight line and markers option. There we have our graph. Let's expand it, make it larger so it's easier to view. The graph looks good. However, we need to do something to make the graph look better and more readable. Remember, all figures and tables in a lab report must stand alone. So first, let's label our graph. Click the title, and let's change it. Then we need to label both the x and the y-axis and provide a description for it. First, go up to Chart Element, select the chart axis, primary horizontal, and you'll see that you get a space for describing the horizontal axis. Repeat this for the vertical or the y-axis. Let's describe them now. Our data now looks pretty respectable with the addition of changing the data along the x-axis. So we're going to highlight the numbers in the x-axis, then we're going to go over to the Format Axis option, select the bars, select the axis options, and here we're going to put the boundary of what the x and the y-axis. Right now it's currently set to 0 to 12. We're going to change this to 1 to 10, so that now our data goes from the end to the other end without any space. So at this particular point, the data looks very respectable. However, we can add some additional cosmetic changes to make the graph more inviting and easier for the viewer to read. The first thing we can do is to make the text darker. So we're going to select the text, choose the text option, choose the text fill, and go to color. In the color section, pull it down and select the dark color. Notice how much darker the text is now and how much easier to read. Repeat that for all the other text that you have in here. That includes the numbers of each of the axes. Lastly, we have a figure legend here. The figure legend you can include in the graph itself, or you can include it in a figure description. Remember, all figures and tables must have a figure description, just like all of the images in your textbook have a description telling you what it's about. For now, we're going to move the figure legend to the right. So I have highlighted it. I'm going to go to the figure legend and I'm going to move it to the right here. So now our graph looks pretty respectable, showing us the data for each of the 4 gasolines tested. The second part of the demonstration will show you how to extract additional information from the raw data. For instance, the angle or the slope of each line tells us how fast the cars are moving. The slope of the line is calculated by performing what is known as a linear regression, which is a theoretical line calculated from all the data points that were collected. We will perform a linear regression and the software will calculate the line in the form of the equation y equals mx plus b. In the equation, m is the slope. First, we will copy the graph. Select the graph, select the copy option, find a cell below the graph, and then insert the graph with paste function. Now you have an identical copy of the graph. Then select one set of data points by highlighting them. Go to the Chart Design option, go to the Add Chart Element option, select Trend Line, and then further select more trend line options. You'll see that a dotted line has been drawn, and that corresponds to a linear regression analysis. You also want to check the display equation on the chart box. And now the software has given you an equation for that dotted line. Within that equation, m in this particular instance is 159.39. You will repeat this for all the data that you've collected. And then from each of the data points, you will calculate what the slope is and then plot the slope versus each of the conditions that were tested. Note that your lab report should not contain this second graph, just the slope data. Your lab report should contain the first graph of the raw data. At this point, our demonstration is complete for the most part.